This edition of Conjugated or Not, we're going to talk about whether these compounds are conjugated or not. A or B. So we have 5 compounds here. We just learned about what conjugation is. So we should be able to tell if these molecules have conjugation or if they don't. And there is one of these that is a little bit tricksy. So pause the video, decide for yourself, and then we'll check the answers after you're done. Boop, paused, boop, unpaused. Okay, this one is conjugated. Overlap of those two pi bonds. This one is not. It's got a CH2 here, CH2 here. Both of those are sp3 hybridized. They break up the conjugation. This one is conjugated. This bond is overlapping with this bond. This one is conjugated. This pi bond is overlapping with one of these pi bonds. And lastly, the one that's a tricksy little hobbit is not B. Okay, so these ones were relatively straightforward. Hopefully you had no problem working through those on your own. This one is a little bit different, and I added an H there that was not on the note packet, so now it's fixed. Okay, so why is this one not conjugated? It looks like we have a pi bond and a pi bond. Pi bonds are in p orbitals. Why are they not overlapping? And to answer that, we have to think about what p orbitals are. And when we learned about orbitals in the first place, we said there's an s orbital and 3 p orbitals. And what else did we say about those p orbitals? We said those p orbitals were on axes, right? This would be maybe a px, a py, and a pz. So let's think about this central carbon atom here. This central carbon atom has 2 molecular groups around it. So it's going to hold them as far apart as possible, which is 180 degrees. So this is going to be sp hybridized. So to become sp hybridized, that central carbon would have combined its s orbital with this p orbital, and in its hybrid form, it would have had 2 sp orbitals. Okay, let's make them separate. 2 different sp orbitals, and then we'll say a py orbital and a pz orbital. Okay, so what does that look like? Well, if we draw this one out a little bit more, we know that that center carbon atom is going to have 2 bonds to the carbons on the other sides. And these sigma bonds are made from a carbon sp orbital, and then these carbons here are technically sp2 hybridized. So it's a carbon sp to a carbon sp2, because this is sp2 hybridized, this is sp2 hybridized. But what p orbitals are making these bonds? Well, we'll just say, for no specific reason, that this carbon is bonded to this carbon in the py orbital. So if it's the py orbital on a graph where this is the x-axis, this is the y-axis, the z-axis comes out of the board and goes into it, the y orbitals are going to be up and down. So the electron density is above and below this carbon-carbon bond. What about the other carbon-carbon bond? Well, in this case, we've already used our py orbital. We only have our pz orbital left. So what that means is that the orbital would have to come out toward you and go into the board, because that's where that pz axis is. So we're going to draw that like this. So there's an overlap of that orbital and an overlap of that orbital. So essentially, what we have here is that central carbon atom has 2 p orbitals that are like this. They're crisscrossed. And because of that, if they were to be overlapped, they would need to be in the same axis. So they would need to be in the same axis if they were overlapping, but because they are on opposite axes, they are not overlapping. So this is a non-conjugated system. That's the molecular orbital reasoning behind why this is not conjugated. What was the other thing that we could do to check ourselves to say, is this system conjugated or not? And what we said we could do is draw resonance structures and see if they are valid. So for instance, on this one, we said we could draw a resonance structure like this, which we move the electrons up there, so that's negatively charged. We move them away from that one, so that's positively charged. Let's try and draw a resonance structure for this molecule. Well, if we drew that like this, and let's try and overlap this CC pi bond onto that area, like we did here, where we moved it between two other bonds. If we do that, if we just follow the arrows, so you might want to pause the video again and see if you can draw what we just kind of did up here. What you'd end up with is a positive charge on that carbon atom. This carbon atom here would still be double bonded over here, which would make it also positively charged because it had 4 bonds, now it has 3 bonds, and then this carbon on the end would have to have 4 bonds and a lone pair, which makes it 2 minus charged. So first off, all of these charges, too many charges, right? That's crazy. We would never have a molecule like that. 2 negative on 1 atom, we've never seen that ever. But also, what's wrong with this structure? How many electrons does that carbon have? That carbon would have 2, 4, 6, 8, 10 electrons on it. Again, this is a Texas carbon. Too many electrons, so we can't draw that structure. So this is the molecular orbital view of why it's not conjugated, and then we can't use our resonance mnemonic to show overlap either, so this must be a non-conjugated system. So I hope you enjoyed this edition of Conjugated or Not.